All right, hi again, you guys. This is example number 3. And if you take a look at this function, we're going to be doing the quotient rule to take that derivative. So to find the derivative of this, here is our function. This is where we have our high and our low. So again, what is that? Low times the derivative of the high minus high times the derivative of the low, all over the low squared. So our high function is the negative 2x. Its derivative is negative 2. The low function is x plus 2. Its derivative is 1. So we would have the low times the derivative of the high, put some other parentheses around here, minus the high times the derivative of the low, all over the low squared. And that would simplify down to, we would have a negative 2x minus a 4 plus a 2x all over the x plus 2 squared, which ends up giving us negative 4 over x plus 2 squared. So now we're going to take a look to find the critical values. And in this case, there is that one where there would be undefined. So we would have x is equal to negative 2. And just to be sure you know where that came from, we had that x plus 2 in the denominator. And of course, the denominator can't be 0, so we have that critical value of negative 2 where it would be undefined. So now we are going to do the number line test. So we're doing the number line test. And again, our critical value is negative 2. So we're going to pick values on either side. And again, negative 3 and 0. We are going to plug those in to the derivative, which is the negative 4, negative 3 plus 2 squared, which would give us a negative value. And if I plug in the 0, I'm going to have negative 4 over 0 plus 2 squared. And again, that's also going to give us a negative value. So it's kind of like, well, they're both negative. What's going to happen with this one? So the left-hand side of the negative 2 is negative. The right-hand side of that critical value of negative 2 is also negative. So what might that graph look like? So now we're going to do our sketch. And in this case, we are going to have a horizontal asymptote that would go along here. We also are going to have that undefined one at negative 2, which would go there. And it's telling us that the function left of the negative 2 is decreasing and right of the negative 2 is decreasing. So going that way would be decreasing, and going down that way would be decreasing. So again, we're just kind of looking at the information we have to turn around and sketch the function. See you next time.